So the most exciting thing to me about Artemis II is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. The moon is this great sort of chiaroscuro subject because the most recognizable thing about it is the changing sun angles and how that brings out the shape of craters near the terminator, which is the day-night line. Because there aren't, oceans and clouds and all the things that you see on Earth, the moon is really all about its shape. And the shape is telling you something about its long history and the history of the entire solar system. All the things that have happened to the Earth have been erased by geologic processes and weather and climate, and that doesn't happen on the moon. The moon has recorded everything that's happened since its formation almost 4.5 billion years ago. That tells us a lot about where we came from, where the solar system came from. It also reveals something about the composition of the Earth that we can't see because it's buried beneath the crust. Some of that is on the surface of the moon because it's been excavated by all the impacts. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis II will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Oriental. Oriental is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Oriental has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than the near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission. One of the photographic targets that is on everybody's list is pictures of the Earth beyond the limb of the moon. During Apollo 8, on their fourth orbit, they finally turned their spacecraft around so that they could see in the direction of the Earth.
Oh, God, look at that picture over there. There's the Earth coming up. Wow, that's pretty. Hey, don't take that. It's not scheduled. You got a color film, Jim?
I think it surprised all of them how beautiful and how human it was to see the entire planet Earth from behind the horizon of another celestial body. That photograph called Earthrise had a huge impact on the public because from space, you don't see country boundaries, you don't see some of the human problems that we deal with on the surface. And you also recognize that the Earth is a finite place. It's not infinite, it's not everything. It is a pale blue dot in the vastness of space. Artemis is going to have that opportunity once again. I anticipate that the astronauts will have the same feeling that the Apollo 8 astronauts did, and I think it will have a similar effect on a new generation of people who are watching this mission unfold.